Hello guys, welcome to my YouTube channel Learn to Code with Noob. So today in this video we will discuss some other important concepts in TypeScript which are more of on the object oriented side. These concepts are today we will discuss inheritance, access modifiers and generics in TypeScript. And I also want to say Happy New Year to all of you guys, and let's jump in right into the concepts. Alright, so moving on to my next topic within the class, or the next concept of object oriented programming, is inheritance. So in the same way as in other languages we can use inheritance, in the same way we can do that in TypeScript. So for example, you have a class, let's say manager, and if you want to inherit employee class manager, so then you just do this, and what this will do is it will actually will have all the properties of employee class. So right now in employee class we have name property, and this same property will be inherited by the manager class. So if you want to have a name passed into the constructor, so you can do this, and in order to pass the value up to the employee class you can call super, and in super you can pass in this name, and then you can have a method, let's say name, and then you can't have a method with the same field like name display or something like that, and it will print the name property. So it can be name of manager is name, right? And then you can create an object of a manager, let's say manager to new manager, you pass in the name, say the manager name is Bruce, right? And then you call on the function display, right? And you can see like in this manager you are also able to access the greet method which is in the employee class. So yeah, simple example of inheritance in TypeScript. Alright, so moving on to our next topic, which is access modifiers in TypeScript. So we have basically three access modifiers in TypeScript: public, private, and protected. So if a property is if it has nothing in front of it, like no access modifier, it is public by default. So you can actually write public in front of it. If you don't write, it doesn't matter, it is public by default. So public means like if you define a member of a class as a public, so if it's a public member, then it is accessed all over, like in the derived classes too, and all the like subclasses. And if you define the member variable as private, so let's say I define it as private, then you can't access it in the derived classes. You can access it in the base class, like in the class which that private is defined. So I can access this name over here, right? In fact, I can actually write console.log and this dot like name, I can easily access it, right? But I can't access this name over here in this method in my derived class manager, so I can't do that. The next is protected. So protected is basically is an access modifier which kind of behaves like a private, but the only variation to this access modifier is that the property can be accessed in the derived classes. So what that means is you can, like, I can access the property in this manager subclass, so we can access that. But here is a quick gotcha. So in Java I can actually do this. So what I can actually do is, so for example, if it's a manager subclass, right, I can do is I will just do manager 2, and what I will do is I will just do new employee, right? I will define an employee name which is Bruce 2, and if I'll do mg2 dot, and I can, sorry, the name variable. So in Java I can do that. I can access the name variable by the instance, right? But I cannot do that in TypeScript because so TypeScript follows the convention of C++ and C sharp, in which it basically says, like, if you are trying to access the method, right, which is which is basically, if you're trying to access a member which is protected, right, a protected member with an instance of base class, you can't actually access it. But if you do this, so for example, if I do this, like this, this will work. And this will work because this is actually same as calling this dot name, right? So you're basically calling this property, this protected property, by a derived operator, which is this, right? Sorry, by a derived keyword, which is this. But you can't do by the instance of a base class. So this is a little gotcha in the TypeScript. But if you are coming from a C sharp and C++ world, it is kind of clear for you. But if you're coming from a Java world, this might be a bit weird. But yeah, this is one of the gotcha in the access modifiers of TypeScript. Alright, so today we are discussing the one of the most important topic and powerful topic, which is generics in TypeScript. So one of the best features of TypeScript is, like, it gives us that type static type checking whenever we are writing the code, and as we know, which is very powerful aspect of TypeScript. So in other object oriented languages such as Java and C sharp, we actually use the power of generics, which basically allow us to create reusable components. And the same thing we can do in TypeScript. So in TypeScript, you can basically create reusable components. So we will go step by step how TypeScript works in each and other aspects. So the first thing we are discussing is generics in function. So how we can actually define generics in function. So let me take a straightforward example. So for example, you are defining a function, right? Let's say that function is same, and it is a very simple kind of function in which you pass in the value and you return the same value. This is your function, right? So if you want to use this function, for example, over here, like const v equals same, and you pass in the value, for example, a string as 2, something like that. So you will notice, like if I hover over here, right, you will just see that v is of type any, right? And this is um, a bit weird in TypeScript world if we don't know actually the return type of v. So in order to fix this, we will use the powerful concept of generics. But before that, why we actually need generic over here? So for example, if I want to use this same function with other types, technically I can use it as it is, as 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 I have defined it over here. So for example, if I want to pass in a number, I can pass in a number and it will work. Like if I pass in a number, the v will be number. But if you hover over here, TypeScript still doesn't know the type of this function. So this is where we lack the type strict checking. So for example, if I want to say, hey, I only want to use this function for a particular type. So for example, what I want to say is, like if I am passing this it as a string, I just want a return type as string, and I want the TypeScript to check that for me or make sure that this is what I am getting as a return type of that function. So how I can do that? So I can do that by utilizing the power of TypeScript, in which I can say that the like angle brackets t, it basically, this basically means is that this function will accept a type of t, or this function is generic, right? And this argument colon t is that it will accept the parameter of type t. And if we want to be more specific, we don't have to declare it over here, but if you want to be more specific, you can just say that the return type will be t. It will be implicit by TypeScript. Like if you will not define it, it will behave as same. But if we want to understand it, then we can actually define it that the return type of this function will be of type t. Now, this type t I have used, you can actually use anything over here. So you can just basically say param, right? But you have to make sure, like whatever you are defining over here, you have to define the same thing over here and over here too, right? So you can do param, like this is just a name thing. You can define anything, so whatever makes sense to your code base. So usually we define t as I've seen more, like this is the convention, and this is the convention like most of the developers use in other object oriented languages. So that's why I defined it as a t over here. So what this is saying is that this function is generic of type t. It accepts the parameter of type t and returns the value. This function returns a value of type t. Now, as soon as I declare this function as generic, now if I will hover over v, it basically says that okay, this v will return me 2, right? Like it basically says that okay, this is a number, right? And if I just do this, it will say this it will return me a string, right? So over here, right over here, it is type checking for me. And if you see that I have made this function reusable, and it is also checking the type for me. So the TypeScript is automatically checking the type for me, and it is also reusable. So let's say I want only this function, like for example I want to override that, hey, on line number 8 I don't want you to pass a number over here, like just making sure. So what I can do is I can do this, right? Now TypeScript will give me an error and say, okay, hey, if you are expecting a number, then this is not a number. So just correct this thing, and now over here I'm basically overriding the generic function. So I'm basically saying that, hey, over here on line number 8 I specifically want a number type to be passed into this function as a parameter. So this is how you declare generics and functions. This is a very simple example of that. Alright, so moving on to our next concept in the generics function is the type variables stand in for any and all types. So what that actually means. So for example, you have defined a function which is consuming a generic parameter of type t and is returning the same type t. So for example, if you change this function like this, so over here you just say console.log and you just say arg.length, right? So if if you are changing the function like this, it will give you an error, and the reason of this error is that type variables stand in for any and all types, which means is that this function TypeScript is basically assuming that this function type parameter can be of any and all types. So it means it can be of any type. So for example, if I am passing a number, the number doesn't have a length property, right, into it. The length is not a property of type number. Also, if I pass string, the same thing happens. If I pass a number, and if I pass a boolean too, the same thing happens, right? So I have to if I have to use this function, then I have to make sure or check that if this parameter which is passed into this function has this length property or not. So suppose if we are saying, okay, actually I want to change this function to actually consume, so the input parameter of this function will be an array type. So then we have to change this function to have the array type in, right? And obviously if the array type is the input, and if I'm returning the same array type, then obviously I have to do this over here too, right? So now it will not complain, because over here at line number 5 TypeScript is sure that the the input parameter which will be passed in this will be an array, right? And array has a length property. So this code is valid, right? And now the power of it is you can define generics of any type. So of any type, which I mean is like of any generic type. And so over here, like if I have explicitly said that this function same is of number, then I can only define number types. And if I don't want to override it, I can actually do this. And over here, then what TypeScript will say is whatever the value you will pass, I will infer it, right? So whatever the value we are passing over here, it will infer that value and that will be the return type. So now you can see the v constant is of type number array, right? And if I change this thing to string, right, then the v is of type string array. So that is another point. So whenever we are changing the function, we have to take care of this point that the variables which we are consuming, which are of generic type, TypeScript is actually assuming that they should be valid for, that the function should be valid for any and all types. Alright, so moving on to our next topic, which is generic function as a type, and we'll also discuss generic interfaces. So let's say if you want to declare a variable which is of generic function type. So what I mean by that is, so over here right now we are basically saying, hey, there is a function named as same. It is taking some generic parameter of type t, and this is a generic function, and uh, it returns the same value which is passed in the parameter as an output, right? So if you want to define this as a type of any variable, so for example, I want um, variable v, and I want this variable v to have a type of this generic function type. So what I can do is I can just define it like this, right? And then I can just do this, right? So over here, what this basically means is that this variable is of generic type function, which is basically equals to this, right? So now I can have this variable and I can pass in the value over here, right? So and this will obviously return something, which is, in this case, it will return value of type number, which is 2 over here, right? So we can define a variable like this, or like with an arrow notation. This is an arrow notation, same concepts as like lambdas in Java, something like that. And if you can actually define this as a object literal call to, like you can do this, and over here you can do this, and this is the same thing as the previous. So notice like this whole notation is kind of like the same, like okay, here there is a function which accepts type t. Over here it's a bracket starts, it has a parameter, right? And it returns of type t, like, but if you are saying that it returns of type t, then you have to actually provide this as an object literal. But if you don't want to provide it as an object literal, you can do this by by the arrow notation. It is basically the same thing as like how if you want to define this function as a arrow function, you can do like this, right? Same, and then you do something. So it is kind of the same thing like this. And in this arrow function, right, you're basically saying that, hey, this is t, right, and it takes a value something, right? And oh, because these are same, I can just say same one, right? So these and these things are same. That's what it actually means. And if I don't have this, you can include it into the object literal and do this, right? So um, so these are generic functions as a type. Now moving on to the interfaces. So if I want to declare this whole thing as an interface, I can actually do that too. So I can do like interface, like, and I will just rename it as another I, right? And then I can basically copy this whole thing and I'm done. So I can actually write let v2 is another I equal to same, right? So these and these two things are basically the same. But what if, so here is the other thing, like what if I want this another I to actually work for a generic, like for a particular generic type, right? To accept a particular generic type. So what I can do over here is if I will try it like this, right, it won't work because I am actually not saying the interface to accept a generic type, but I can do it like this. So by use of this, like this is the same thing which TypeScript does for arrays, right? So if you think like, so okay, here is an array or array 2, and if I want to define array as a generic, so if an array is generic, like it will do like this, right? But if the array is not generic, if I want to explicitly type in that hey, this array variable should accept an array of type string, I can do it like this, right? A type of string, then I can do it like this, right? So now I can't like just do array 2 and then put in a number, right? Maybe I can, oh sorry, so this means, so I can't do like this, right? Like on the first index I can't write a number, and I also can't do, I believe I can't do as this too. So this is basically I'm making sure that only array of type string is provided, right? But as you can see it over here, like over here I can actually override this function, right? So for example, let's say I have a v, right? Like I just do same, right? And I pass in a string, right? And I will just override it to pass in a number. So technically I'm not making sure that this thing is as a string. I mean, you can do that in a function, but if you define, but if you want to define it over here as a string, right over here, right, you can enforce it in the interface, like, and you can pass in a string, and it will make sure that only string is passed in, not any other type, right? So over here, if I'll say like v2 another I is string, so I can only pass in as a string. I can't do number, which I think, so I can't do number, sorry, I can only pass in as a string in the v2. And number is accepted. So alright, so I think, so I found an issue with that. It's just the interface how I have defined it. So it needs to be defined it like this. sorry, like this. So now, yeah, so now it is making sure that this should be a string. So if I define it as string, this should work, right? So before that, what was happening is I did this, right, which is incorrect because I'm technically not using this type. So what I need to do is to do this. Now this will make sure that whatever the type I am passing, this will obey it. So yeah, so this is how you can define generic interfaces too. Thanks for watching, guys. If you like this video, please don't forget to click on the like button. If you don't like this video, please mention why in the comment down below. Like, share and subscribe. Keep learning.